Hello class, today we're going to be 13-3 absolute value inequalities. So today we're going to solve absolute value inequalities. So for what we know about absolute value inequalities, remember that when it's an absolute value equation, we broke it up into various piecewise functions. Well, if we're talking about absolute value, that means that all has to be positive. What's going to happen is, without really going into the complications of the geometry, a statement like this would kind of break up into various piecewise functions, because we know that's how we model it. And instead of breaking it up into a bunch of those different piecewise functions, we're just going to memorize a few things instead. If I have the absolute value being greater than 0, this is going to create an OR statement. And so a good way to memorize this is going to be the phrase greater than. If we have a less than symbol, right, so if I have the absolute value of something that's less than 0, this is going to create an AND statement. An easy way to memorize it is to kind of think less than. Now, in the beginning of the class, we talked about these OR and AND statements. We said that an OR statement is the same as union, and an AND statement is the same as an intersection. So we just got to keep that in mind. So this is our first example here, and it says 4 minus 3 times the absolute value of 2x plus 1 is greater than negative 2. So just remember, from what we know of absolute values, we said that if we have an equality statement, the absolute value equals c, we can break this into x equals c and negative x equals c. And so we need to still do that same type of logic, or that same type of statement. So I need to apply that logic to this absolute value statement. So I'm going to minus 4 on both sides. Negative 3 times the absolute value of 2x plus 1 is going to be greater than negative 6. Divide both sides by negative 3, and I get the absolute value of 2x plus 1 is going to be less than 2. So now, being able to break this up, I'm going to get 2x plus 1 is less than 2, and because it's an AND statement, because it's less than, I'm going to get and negative 2x plus 1 is going to be less than 2. Now solving for each of these equations, minus 1 on both sides, 2x is going to be less than 1, divide by 2, I'm going to get x is less than 1/2. And then for this one, divide both sides by negative, I'm going to get 2x plus 1 is going to be greater, and that's going to be the negative 2 minus 1 on both sides. 2x is going to be greater than negative 3. Divide both sides by 2, x is going to be greater than 3/2. So now on our number line, to represent this, we have x is less than 1/2. And then we have, we'll say here, I'll do this one in red. So I have x is greater than negative 3/2. Now my answer is the intersection of the both, because and means it's intersection, and so where do they both exist? That's going to be here. And so my answer is going to be negative 3/2 all the way to positive 1/2. Or I can write this as negative 3/2 is less than x, which is less than 1/2. Example number 2. So I'm going to subtract 8 on both sides. Absolute value of 4x minus 7 is going to be less than or equal to, and this is going to give us 9. And so now, because it's less than, I'm going to know that it's going to be an AND statement. And so now solving this, applying the definition, I get 4x minus 7 is less than or equal to 9, and the negative 4x minus 7 is going to be less than or equal to 9. So solving for each one, if I add 7 to both sides, 4x is less than or equal to 16. Divide by 4, x is less than or equal to 4. Divide both sides by negative, 4x minus 7 is greater than or equal to negative 9. Add 7 to both sides, 4x is greater than or equal to negative 2. Divide both sides by 4, and I get x is going to be greater than or equal to negative 1/2. Now I did divide by negative, so I do need to flip my sign. So now I have these two statements, so I need to model it. So here's my number line. Here's 4. It's going to be a closed circle this time. And we said x is less than 4, so that's going to be everything less than 4. And then on my next one, we said x is going to be negative 1/2. And I'll draw it right here. And so that's going to go on. And so because it's an and statement, and means intersection, so it's where they overlap. Meaning if I smush those two lines together, where do they overlap? And it overlaps from here all the way to here. And so I can say that's negative 1/2 with a bracket, comma 4. Or I can say x is going to be between negative 1/2 and positive 4. So now looking at this one, I'm going to add 8 to both sides. And so I'm going to, the absolute value of 6n plus 7 is going to be greater than, this is 51. So for this, I know it's going to be an or statement. So now, breaking this up with my definition, 6n plus 7 is going to be greater than 51, or I'm going to have negative 6n plus 7 is going to be greater than 51. Now solving for each of these, minus 7 on both sides, I get 6n is greater than, what is that, 46? No, it's 44. And then applying the negative, I'm going to get 6n plus 7 is less than negative 51. And so I can subtract the 7. So I'm going to get 6n is less than negative 58. So now continue to solving for both of these. I'm going to get n is greater than, that's going to be 44 over 6, so I can reduce that. That's going to be 22 over 3. And then dividing both sides by 6 here, I'm going to get n is less than, and this is going to be 25, half of 8 is 4. So that would be negative 29 over 3. So now let's model this. So on my number line, we'll say that this is negative 29 over 3, open circle, and it says x is less than that. And then the other one, it says n is greater than 22 over 3. So let's say this is 22 over 3, open circle, so it's not equal to, and it says n is greater than that. Well, an or statement means you include both. It's union. So including both, I have negative infinity all the way to negative 29 over 3, union from 22 over 3 to positive infinity. Or I can say n is going to be less than negative 29, or n is going to be greater than 22 over 3. So both of these statements would be correct. Now let's take a look at this one, because this is where some strange things can start happening here. I know that I have this absolute value of 6n plus 7, and we'll kind of consider this a special case. And the reason why is a special case is because this is greater than a negative number. Whenever we deal with negative numbers on this side of an equation, we always know like kind of goofy things happen. If that was an equality, like an equal sign, we know that it can't equal a negative number. So what we're going to have to do instead is, if we just stick to our definition, we can see what's going to happen. So since this is greater, I know it's going to be an or statement. So I get 6n plus 7 is greater than negative 4, and then negative 6n plus 7, and that's going to be greater than negative 4. So then solving for this, this is negative 7. I get 6n is greater than negative 11, divide by 6. I get n is greater than negative 11 over 6. For this one, dividing both sides by the negative, I get 6n plus 7 is going to be less than 4. If I minus both sides by 7, 6n is going to be less than negative 3. Divide both sides by 6, I get n is less than negative 1/2. So now let's take a look at what happens here. On my number line, I have n being right here. Let's say negative 11/6. It is open circle, and it says n is greater than that. So that's going to be everything here. And then I have n being negative 1/2, which we could say is about right here. Oh, why not? So let's just say this is negative 1/2. But then n is everything less than that. Well, an OR statement means union of both. So I include both solutions. Well, everything here happened to be shaded. So my answer is going to be negative infinity to positive infinity, or x is an element of all real numbers. It's infinite solutions. And the reason being is because every single value is going to have to be greater than my negative value there. It just has to be, because you can't have a negative. So every single value is going to work for my absolute value. Now what happens if this is flipped? Now if we did this flipped, what's going to happen here is now this becomes an AND statement. And so if I did all of the work, I'm going to get n is less than negative 11/6, and n is going to be greater than negative 1/2. And so if I wanted to take a look at those and put these on the number line, here's negative 11/6, n is less than that. For this one here, this is negative 1/2, n is greater than that. Well, if you notice, there's nothing that intersects, because that's what AND means, is that they intersect. So because nothing intersects, there's no solution. To close today's lesson, what did we learn today? Well, we learned how to solve absolute value inequalities. And there was a few things that we had to pay attention to when we were solving these absolute value inequalities, and in OR statements, and the fact that sometimes the absolute value creates an illogical statement. Now, what type of statement does a greater than or equal to make? So is that an and or statement? And then what is a way to memorize that? So there was kind of like a trick that I used to kind of help you memorize that. This does conclude our lesson. If you have any other questions, please leave them in the comments.